Alright, so on this graph, we have plotted all the points. If we connect them, we get a nice straight line, making this a linear function. Think about the slope. You're taking your rise over your run. You went up 3 to the right 1, so your slope is really 3. Okay, we have 3 different forms for an equation of a line. We have slope-intercept form, standard form, and point-slope form. The one you're probably most familiar with is going to be the slope-intercept form. We call it slope-intercept form. Your y equals mx plus b, because this m value, your coefficient in front of the x, is your slope, and this b value is your y-intercept. Right, you're at 0 on the x-axis, and you go up b units. That's where it would cross the y-intercept. That's where it crosses the y-axis. So here's some information. We want to write the equations for the lines in slope-intercept form. So if they gave us that slope in the y-intercept, all we'd have to do is plug it into our equation. So here would be our m value, here's b. So we'd have y equals negative 4/3 x plus 2. This is a great review from algebra. You've done a lot of stuff with lines before. Given the y-intercept and another point, then we'd have to figure out the slope. So take your y2 minus y1 over x2 minus x1, which is really 7 minus 4 over negative 3 minus 0. So that would give us 3 over negative 3, or negative 1. So now that you know the slope, plug that back in. We have y equals negative x, or negative 1x, plus 4. This again was our b value. Here was our slope. Plug those into the equation. What just happened? Alright, given 2 lines, make sure you change that to a positive 5 here. Okay, so first find the slope. That's our first step. We are finding the slope. We're taking negative 1 minus 2 for the top, 6 minus 5 on the bottom. That gives us negative 3 over 1, or negative 3 for the slope. Second thing we need to do is plug that into our equation. We know the slope is now negative 3. Okay, we also can pick an x value and a y value and plug those in. Here I'm going to plug in, substitute the point 5, 2 into the equation. So my y value is 2, negative 3 times 5, 5 is my x value, plus b. Now I'm down to one variable. I can just solve this for b. If I add 15 to both sides, we get 17 equals b. So your fourth and final step then would be to plug in your b value into this equation. So we have y equals negative 3x plus 17. If you were given a table, you need to first pick 2 points from the table. I'm going to pick 3, 3, and 4, 7. Now that I know 2 points, I'm going to find their slope. Just like we did before. 4 minus 3 over 7 minus 3 will give us 1/4. oops. Help if I put the y's on top here. 7 minus 3 over 4 minus 3, we get 4 over 1, or 4. So there's our slope. Then we need to plug that into our slope-intercept equation. Pick one of these points here. I'll pick 4, 7 and plug that in. So now we have, for our y value, 7 equals 4x, oops, 7 equals 4 times our new x value of 4 plus b. We need to solve this for b. So we need to subtract 16. So we end up with -9 equals b. And your last step then is to plug that into the equation. So we really have y equals 4x minus 9. That's the equation for this line. Okay, a relation is just a set of inputs and outputs. You have x's, you have y's. For a function, that's a relation. You have inputs and outputs, where each input value maps onto exactly one output value. So we're trying to figure out, are these relations functions? Well, if I look at my input here of 3 and 3, do they have the same output? No, one time you get 4, one time you get -6. So is this a function? No. The input value of 3 maps onto 2 output values, and then we have to name them. 4 and -6. Okay, here's our mapping diagram. We have -2 that goes to 4, 2 that goes to 4, 4 maps to 16, 5 maps to 25, 6 maps to 36. Is this a function? And this is yes. There's only one arrow going from each of these inputs. So you can say each input value has exactly one, each input value maps, I want to use that word maps, onto exactly one output value. And this last one, we talked about something called the vertical line test. If you had a vertical line, if we use this vertical line and drag it across the graph, is there anywhere on this graph where the points hit the line more than once? So here, these points have the same input value, but they're giving 2 different output values. So that's what makes it not a function. It does not pass the vertical line test. So each input value does not map onto exactly one output value. So this is when it fails the vertical line test. That should be familiar from before. All right, so here's our function notation. Here's our output, y. This letter here is the name of the function. It's usually f. Sometimes it'll be other letters. And x is your input. When you see this, read it as f of x. Okay, so if we want to rewrite using function notation for every y we see, we're just going to replace it with f of x. So here we'd have f of x equals negative 3x squared minus 5. Everything else is the exact same. Same with b, f of x equals negative 5/7 x plus 3. And when we're looking at that function notation, if f was 3, this used to be f of x. So that means for every x we see, we're plugging in 3. So we have f of 3 now equals 3 squared plus 1. We don't do anything on this left-hand side. We do all of our work on the right. 3 squared is 9 plus 1 gives us 10. So we can really say f of 3 equals 10. When we have f of negative 1, plug in negative 1, and for each x you see, that's negative 1 squared plus 1. So just drop this down. Nothing on the left-hand side here changes. Negative 1 squared is really a positive 1. This is 2. So we have f of negative 1 equals 2. F of 0, plug in 0 for each x you see. Drop this down. This will give us 0 plus 1, so just 1. So if you have f of 0, there's 1. And our last example, you've got a new function. This one's called g of n, so plug in these values. Got g of negative 4, that would equal negative 1/2 times negative 4 minus 7. All my work's done on the right. Negative 1/2 times negative 4 is 2 minus 7. That gives us a negative 9. Oops, so this is g of negative 4. It's really negative 9. G of negative 15, plug that in. Negative 1/2 times negative 15. So negative 1/2 times negative 15 would give you 7.5 minus 7. So when we plug that in, we end up with 1/2, or 0.5. And g of 10, when we plug that in, negative 1/2 times 10 minus 7. This is negative 5 minus 7, so we get negative 12 for g of 10.